Greetings to you all. I hope that all of you are having a nice day. My name is Jafar Bavcic and I'm going to lead you through this Nmap course. I am a penetration tester and a security consultant. I am interested in almost anything that is security related. Reason why this is called the no-nonsense Nmap course lies in the concept of the course itself. As you can see, the course is simple and not too long. You won't be bothered with anything that is not important for directly developing your knowledge and skill. The course lasts a bit more than 2 hours, but every minute of it, I mean literally every minute of it, it is packed with content. I made this course with an idea that it should be easily applicable to the real-world applications. You will see that when you enroll yourself in the course and go through the tutorials. One of the most important points of this course, and why this course differs from the other similar courses, is that content of this course will be continuously updated and enhanced. That will be based on my own findings, your suggestions and problems, so you are not paying for finished content, but you are paying for a service instead. In terms of prerequisites, you will need mostly basic hardware and software. So first thing that you will need laptop or desktop computer with more than 4 gigs of RAM. 8 to 16 gigs is what I would recommend, because you will be running virtual machines and similar things while doing this course. Then you will need basic networking hardware, router, modem or switch, which 100% of you, I believe, have. So you will need that in order to practice on your local home network. It is very important that you have stable internet connection, so you won't have problems while going through the course. You should have Oracle VirtualBox installed, preferably with installed Kali Linux or similar penetration testing distribution. And probably the most important prerequisite of all is to be familiar with Linux and Windows operating systems. By doing this course, you will get a couple of things. First of all is that you will learn Nmap command line, the basics of Nmap functionality and usage. Then you will learn how to utilize different concepts within Nmap through very simple command line that this application utilizes. You will learn how to explore networks, identify hosts and devices on the networks in different ways. Each way is optimal for a specific scenario. You will learn how to enumerate local and remote hosts, ports, services, and service versions that are running on those hosts. You will understand in a very simple way what is the difference between using Nmap on Windows and Linux, and you will be able to use all of that knowledge for penetration testing and various security and administrative tasks. And of course, you will learn to use some very interesting methodologies and concepts. I won't spoil anything for you yet. What you won't get in this course is boring and endlessly long theoretical information. There will be no school-like approach. You will start to use Nmap from the first minute of this course, till the very end. I am very proud to say that I excluded all possible fillers from this course, so there is no content that has the primary use of making the course longer. There is no anything like that here. And most important point is that you won't be bored, because Nmap is very interesting and it's useful. Now we will briefly cover the content of this course. There is 7 chapters, which will cover the following topics: installation and setup, where you will learn how to install and set up the Nmap. Then fundamentals and Nmap basics, you will learn how to use Nmap in very basic and simple way. Then you will utilize that knowledge by learning about gathering information, network exploration. More specifically, you will dive into the web servers, mail servers, and large networks. The chapters in this course are ordered in such a way that it will be the easiest way for you to understand the functionality of Nmap. Also, it is very possible that I will add additional chapters in this course in the future. If you are ready and have all the prerequisites prepared, it is time for you to start with this course. We will start with the installation and setup of Nmap. Good luck! Now we are going to install Kali Linux in VirtualBox environment. First thing that you need to do is to open a browser of your choice and then run search query Kali Linux VirtualBox. In the results you are going to get Kali Linux custom image downloads, actually the first result, and the one that you are going to click. When you entered a web page, you are going to scroll all the way down to the bottom. Then you are going to click on Kali Linux VirtualBox images, where you have two variants, a 32-bit and 64-bit. You are going to download a 64-bit version. If you want, you can, with no problems, use and download another one, but in this course we are going to use a 64-bit one. Here you can download this VirtualBox image, even with a torrent, but we are going to use regular download. Just click on Kali Linux VirtualBox 64-bit and save a file in your desired destination. Now I'm going to wait for a download to finish. Since I already downloaded the VirtualBox image file, I'm going to skip that step and open the destination of our download. When I opened the download destination, I'm going to open a VirtualBox and click File drop-down menu. Under File drop-down menu, I'm going to click Import Virtual Appliance and I'm going to navigate to the download destination of VirtualBox image. Next thing that I'm going to do is I'm going to copy the destination of Kali Linux VirtualBox image and paste it to a import of virtual appliance. When you finish that, just select the VirtualBox image and then click on Open. Then press Next and leave the settings as they are. Here you have option to change the destination of import of VirtualBox image, which is what I would recommend if you have a dedicated storage drive. And after all of that, just press import and wait for the import to finish. Depending on the speed of your storage, this step can take a bit longer, so with the magic of video editing, I'm going to speed up this step. When the import or installation of virtual machine is finished, just select it and then press the green arrow button, which is labeled as Start. And here we have error, which is USB 2.0 controller not found, and luckily for us it's easily solvable. In the error dump we can see that VirtualBox is missing a extension pack or plugin that is used to support USB 2.0. It is USB pass-through to our virtual machine, but in this case you are not going to need it. So let's solve this one by closing the error dump and going to a newly installed VirtualBox machine by right-clicking on it and pressing Settings. Then inside Settings, just go to the USB and then select USB 1.1 OHCI controller. This way we are going to bypass USB 2.0 controller, and thus the error won't bother us anymore. While we are in the settings window, we can go to a system and set up some more things. We are going to set a base memory from 4 gigs to 8 gigs of memory. After that, go to the processor tab and select all available cores and threads in order to increase performance of your virtual machine. After that, just press OK and click on the green arrow that is labeled as Start in order to start your virtual machine. But before that, do not forget to select the latest virtual machine that you installed. Now the virtual machine is booting up, and when you get to the bootloader menu, just press enter and make sure the Kali GNU Linux is selected. Then you need to wait till all the drivers and system components are loaded. We are waiting for login screen, where we are going to type username and password. And when the login screen is loaded, the username is root, ROOT, and password is TOOR, reverse of root. After that, just log in inside your Kali Linux system. On Mac operating systems, go to nmap.org, then click download on the left side of the web page. After that, scroll all the way down to the bottom and search for Mac OS X binaries. The latest stable release is Nmap 7.80, so we are going to click on that file and download it. We are going to wait a bit for the file to download, then we are going to open the file and press skip. The step here can last longer than expected. And when the Nmap project window shows up, just click on Nmap 7.80 mpkg. Ignore this warning and click OK. After that, just open the package again. Now inside the Nmap installer, you can change the install location and you can set up a password if you are prompted to. After that, just click continue and wait for installation to finish. And click close in order to close the installation. And if you want, you can move the Nmap installer to the trash. Next thing that you are going to do is open a terminal and test the Nmap by running a nmap command. You can clearly see the long nmap's output, which means that Nmap is installed and working with no problems. Now I'm going to demonstrate how to install Nmap on Microsoft Windows operating system. It is pretty simple and pretty straightforward. Since a lot of you are used to installing softwares on Microsoft operating systems, then it will be a no major problem. First step is, of course, opening your web browser. You can use whatever web browser is available to you. Just run nmap search query and then press download on the first available result. Then navigate through page and search for Microsoft binaries and press on this exe file. Choose the destination where you want to save the download and press save. And wait for a download to finish. When download is finished, just open the destination of the downloaded file. Right-click on it and press Run as Administrator. Click Agree and click Next. Here you can change the destination of Nmap install. You can choose any folder where you want your Nmap installation to be in. After you finished everything that you needed with installation, just press Install. And just wait for installation to finish. Press Agree on User License Agreement. And inside Installation Options window, just check Support Row 802.11 traffic and monitor mode for wireless adapters. Again, wait for installation to finish. Click Next and finish. Click Next again, and at last click Finish. You are done with Nmap installation. Now just navigate to a desktop. Then right-click on Nmap Zenmap GUI and click on Run as Administrator. Turn off the application, then again right-click on Nmap Zenmap GUI and click on Properties. Then click on Open File Location, which will open the destination folder of Nmap. Press Shift on your keyboard, and while holding Shift, do a right-click on a free space inside a folder, and click on Open Command Window here. Inside a command window, just type in nmap.exe. That is how you install and run Nmap from a Windows command line. First thing that we are going to do is to log in our Debian-based system. This here is Kali, a distribution specialized for penetration testing. We installed this distribution as a virtual machine, and this one has a Nmap already pre-installed. All the distributions for penetration testing always have Nmap pre-installed. And in order to test Nmap and install it, we need to open a command line terminal. You can open two terminal windows and drag it to the right and left side of your desktop environment. When the terminal is opened, just type in nmap to check if the nmap is pre-installed. When we execute nmap command, we can see a big output like this one. If your system does not have nmap pre-installed, I mean the Linux system, it is very simple to install a package such as the nmap. Inside your terminal, just run sudo apt-get install nmap. This command will install the nmap package on your Linux system, in this case Debian. Then just press enter to execute the command, and when you get the output of this command, you can see that nmap is already installed. These are the installation steps for nmap on Debian-based systems. We are running Kali Linux, a penetration testing distribution, which is based on Debian operating system. When comparing Kali to other Debian-based systems, the Kali is by default a root, so you do not need to run sudo before running a commands, because your default user account has already root access to everything. The first and most basic technique when you start with Nmap is to learn how to list open ports and scan remote hosts. It is very important to know that this is the basis of every other type of Nmap scanning. In short, this technique is used to identify live services on a host behind the ports on a network. The most general and widely used term for this type of scanning is port scanning. You should run Linux operating system. Most preferably, you should run Kali Linux, because it's the easiest to work with when you conduct these types of activities and scans. The first thing that you are going to do is open a terminal, then drag it to a right or left side, then zoom in a little bit in order to increase visibility. Before running a Nmap scan against a specific host, we should run a ping scan. Type inside a terminal ping against scanme.nmap.org. And if we see in the output that we are getting ICMP reply, that means that host is alive. Basically, the ping scan is used to test the ability of the source computer to reach a specified destination computer. We can run a ping scan against anything that has a host name, for example google.com. It is very good practice to run a ping scans before running Nmap scans in order to see if the host is reachable, so we don't waste our time scanning a host that we cannot reach on a network. More technically, we are sending the ICMP echo request and waiting for a response. Also, we can see timing of those responses in the output of the ping command. Very useful feature of ping scanning is that we can determine IP address behind a hostname. Now we are going to conduct our first Nmap scan. We are going to do it against scanme.nmap.org, which is specifically tailored by Nmap in order for us to test Nmap scripts and Nmap scanning techniques. Inside your terminal, just type in nmap scanme.nmap.org. Just press enter in order to execute the scan and wait for a scan to finish. In order to add verbosity or to see what the Nmap is doing in the background, we just need to add -v to the command that we just executed. This way, the Nmap is generating a live dump of everything that is doing in the background. Also, it's very useful to use -v or verbosity in order to more quickly get to the needed results when we are conducting penetration tests or any other security assessments. As it is obvious, we can see the discover ports and other information before the scan was even finished. And we got the output. Nmap scan is finished. So on the left side of our right terminal window, we can see the port numbers and the protocols, whether it's TCP or UDP. Then in the middle we have the state. The ports can be opened, filtered or closed, more about that later. And we have service or so-called service banner, where we can identify the type or the name of service. Here we have SSH, SMTP, HTTP, nping echo, and something called elite, which I'm not really sure what it is. Even when we are conducting the most basic Nmap scans, Nmap is doing a lot in the background. If we input a hostname when conducting Nmap scan, the Nmap is using DNS in order to convert the hostname to the raw IP address that is later going to use in the scanning process. DNS is domain name system, and it is used for computers to identify each other on the network. In short, it's used for translating host names into Internet Protocol or IP addresses, which are used by computers in order to communicate with each other. In order to change the DNS service that the Nmap is using, you are going to run a following command: nmap -dns-servers, and we are going to use Cloudflare 1, which is 1111 against scanme.nmap.org. Then we just wait for the scan to finish. While the first scan is running in the left terminal window, in the right one I'm going to demonstrate how to run a custom Nmap DNS scan, which includes two DNS addresses. So we just run nmap -dns-servers, use Cloudflare 1, which is 1111, then add comma, blank space, and we can use another one, which is 4444. This way we are using multiple domain name systems in order to conduct our Nmap scans. In the other terminal window, I'm going to skip the reverse DNS resolution by using -n. And on the contrary, you can force reverse DNS resolution by using -R. In order to do this, just type in nmap -n against scanme.nmap.org. As you can see, we are getting identical results, but the goal of this exercise is that we are changing the inner workings of Nmap. Another very important feature of Nmap is that we can specify a port range when conducting Nmap scan. So just type inside your terminal nmap -p1-30, which means that we are scanning all ports from number 1 to 30. And again, we are going to use scanme.nmap.org. And very quickly we can see the Nmap output. Another type of port specification when scanning with Nmap is that we can select specific ports or multiple specific ports when conducting a scan. For example, we can use nmap -p4444 against scanme.nmap.org. This means that we are going to only scan the port 4444. And as you can expect, Nmap gives us the output of only one port. The same type of scan we can do against port 81. And then again, we can repeat the same scan against port 443. Even you can add the verbosity at the end of Nmap script. And of course, any of these port scanning combinations we can combine with a specific DNS server command. In this case, we are going to use 1111, which is Cloudflare's DNS service. By doing all of this, we covered the most basic concepts of Nmap scanning. I would encourage you to do a lot of scanning in your local area network at home, and to do a lot of scanning against addresses on the internet. One of the most important features of Nmap is service version detection. Knowing an exact version of specific service is very important when conducting penetration tests and other security assessments. When we are familiar with exact service version, then it is very easy to find vulnerabilities for that specific service. In order to conduct a simple version detection scan, we just run nmap-sv against scanme.nmap.org. Adding -v or verbosity is, as always, optional. When this scan is finished, we can see that we have additional column in the output, which gives us the specific version of the services that the Nmap has detected. We can see the exact version of OpenSSH, we can see the exact version of Apache HTTPD, and we get service info, which indicates that the OS behind those services is probably Linux. We can increase the intensity of service detection by increasing the amount of probes. We are going to do that by running a command nmap-sv-version-intensity9. So that's the maximum number of intensity that we can set for the version detection. Again, in this case, adding -v is entirely optional. And here I need to add the hostname in order to do a real scan. And as you probably expect, I'm going to use scanme.nmap.org. We increased version detection intensity, so let's see if our output is any different than before. We just need to wait for this scan to finish. As you can see in the output, we have more versions and services that are identified by this nmap script. This is the direct result of increasing the version detection intensity. Also, there is another very important nmap flag, which is -a, which is a special nmap flag that activates 3 modes inside nmap. The 3 modes are operating system detection, version detection, and script scanning, which I am going to talk about later in this course. The aggressive mode in Nmap is much more likely to be detected because it sends much more probes. In order to run the scan, just type in nmap-A against scanme.nmap.org. The -a flag in Nmap is just a shorter version of -sc, -sv-o, because it just combines those 3 into one, which is in this case -a. Adding -v as a verbosity is optional. Now we just need to wait for the scan to finish. By using -a as a aggressive mode in Nmap, we got a really big output. The additional information that we got using the -a aggressive mode is, for example, supported HTTP methods, which are in this case get, head, post, and options. And we have a very interesting HTTP title which says "Go ahead and scan me." That's because we are scanning scanme.nmap.org. Again, I encourage you to try these scans and commands against your own network and devices on your network, as well as on the internet. Now we are going to deal with finding a live host in local area networks. For this part, we are going to use Windows operating system, mainly for demonstration purposes. Some Nmap activities can be done equally good in Windows operating system as they are in Linux. The only prerequisite here is that we have Nmap or Zenmap installed on our Windows operating system. Navigate to the Zenmap icon, do the right click, click on Properties, and then click on Open File Location. This way we opened the installation directory of Nmap Zenmap package. When you are inside a folder, hold Shift and then do the right click, and then open command window here. In the Open Terminal window, just type in nmap.exe. This will run the Nmap executable for Windows. We are only doing this to check if Nmap is working in correct order. By the given output, we can see that Nmap is working without any problems. And in order to check for live hosts in our network, we are going to do following command: nmap.exe -s uppercase P against 192.168.7.1/24. This means that we will scan all of the 256 addresses on the local network. And anything that there is within that range will be discovered by Nmap. And when Nmap is finished with the scanning of the network, it will output all the devices with their addresses and MAC addresses if they are present on the network. Also, you can see that we even have the names of manufacturers of those devices. We need to check if the Nmap really discovered our own host, actually the one from which we are conducting the scan. So we are going to run a ipconfig command. Inside command line window, just type in ipconfig and press enter. The only thing that we need to do here is to compare the default gateway address to the address of our host that was given to us in Nmap output. Nmap sends raw Ethernet packets even on a local network, but we can override that behavior by using --send-ip command or send-ip command in order to send IP level packets. Unfortunately, this command cannot work here because Microsoft operating systems do not support sending of raw IP packets. So we need to switch to our Linux operating system and conduct the same scan. This is the situation where we see why the Linux distributions are much more suitable for doing this kind of work. Now we are inside our Kali Linux distribution and we are going to retry the command that we previously tried in Windows. So here we are going to use netdiscover command, which is used for discovering live hosts in your network. Regardless of the fact that it's not included in the Nmap suite, this command is very useful for discovering live hosts. All you need to do is just to type in netdiscover inside your terminal and press enter. Then the netdiscover should list all of the live hosts in your network. Parallel to netdiscover command, I'm going to run the host discovery command here in Linux. The command is identical as we did in Windows operating system, just there is no .exe. Type inside your terminal nmap-sp send IP against 192.168.7.1/24. Again, we are hitting on the range of 1 to 256 addresses on our local network. And then press enter. Now, when the scan is finished, just compare the netdiscover output with the Nmap output. Everything should be identical except the format of the output itself. These commands are very helpful, especially if you are a network administrator or penetration tester, because you will find yourself many times in the need for discovering a live host on your network. The sp command or host discovery command can be combined with special scripts that are called NSE scripts. We will talk about them later in this course. There is one script that can be used for host discovery, along with -sp or host discovery flag in Nmap, which gives us very detailed dump about hosts. Inside a terminal, just type in nmap-sp script discovery 192.168.7.1/24. Then just press enter and wait. When you take a look at the output of this script, you can see that it is very big. Inside this script, there are two that are running in background, which are sniffer detect and DNS brute. Oh, and here even we have a hostname of the machine. DNS brute is brute forcing of DNS records, while sniffer detect is used for detection of sniffers that used ARP poisoning in order to conduct man-in-the-middle attacks. Now we are going to deal with scanning using specific port ranges or specific ports. For example, if you are looking for an infected machine that is using a specific port to communicate, or in any other case when you are using for a specific service or open port, and you are not really interested about the rest, you are going to narrow down the port ranges and also by that optimize the scanning performance, which can be very important when scanning multiple targets or we are doing a time-consuming job like a penetration test or network audit. The first command that we are going to run is nmap -p80. Then we are going to run that on google.com and add -v for verbosity. Okay, so here the port 80 TCP is open. Now let's change this port to 443 on the same host. As you can see again, it's the HTTPS. It is open. And let's try again on port 4444. It is open. And again, let's do it on port 81. This one is, as you can see, filtered. Now let's try to scan everything on our own network that is running on port 80. And of course, we are going to use CIDR notation to scan all 256 addresses on our network. Let's wait for a few seconds, and we have the result. So, as you can see, we have scanned all the local addresses and the services that are specifically running on port 80. We even have MAC addresses of those devices. Now let's scan the local host. Local host is basically the computer that you are using, and all the services on the local host that are running on something that is called local loopback. And it is equal to the address which is 127.0.0.1. You can scan it again using the numerical address and the result will be the same. So by now we learned that the Nmap uses the prefix or flag -p for setting the specific port or port range to be scanned. This part of a syntax can be combined with many other scanning methods inside the Nmap. So in one of the previous examples we use the argument P80 to get Nmap to scan and know that we are only interested in scanning the port 80. Using this same method, we can easily scan multiple ports. Now I'm going to do a scan on google.com using the -p80, 443, 2000 and 4444. Everything on google.com. And we will easily check if those ports are closed, opened, or filtered on that host. It's pretty easy, isn't it? So that's how we combine the ports into one scan command. Let's try it again on scanme-nmap.org, and we get pretty much the similar results. Now we are going to scan a range of ports on google.com, a range from port 1 to port 100. The way we do that is pretty easy. We just put a dash between the 1 and 100. Not really the expected result, probably because all the interesting ports with their banners and services are running on a bit upper ports. And this is just the host name of google.com. If you try to scan anything with only -p, you will not get any results at all. But if you add the dash after the p, actually when you have -p-, then you are scanning all the possible ports on that host. And believe me, this type of scan you should only use in local networks, because when you are scanning external hostnames or addresses, it can literally take forever. You can also use the service name after the -p, and we are going to scan the local host in this case. Nmap -p HTTP, and we are scanning localhost. You can also use wildcard when scanning services. That means that the result you are going to get is everything that is related to a specific service. In this case, HTTP. As you can see, there are many services that Nmap output lists out for us. So let's try this with HTTPS. First of all, let's try it without wildcard. Okay, so it's 443 TCP, it's closed. Now let's run it. Let's run the same scan, but with HTTPS with wildcard, and let's see what happens. It's localhost, so those 3 ports are closed. Now try it on scanme.nmap.org, and you get the idea. This type of scanning, service scanning, actually works only on the case of services that are already recognized by Nmap libraries. There is one more method of port scanning in Nmap. It's basically scanning the only ports that are registered in Nmap services and libraries. So it goes in the following way. The basic syntax and symbols are a bit different, so in this case of scanning only registered ports in Nmap services, we are using square brackets. We are putting the range of ports inside a square bracket. In this case, 1 to 65,535. But unfortunately, we are not going to finish this scan because it will literally take forever. But instead of that, we are going to change our host name to our local host. And when the scan is finished, as you can see, we get more than 8,000 ports that are not shown, and the one that is shown is RPC bind that goes on port 111, and it's open in this case. Let's try the same scan, actually the identical command, but only on my own home network, using the full range of 256 addresses. Probably this is going to take a while, but we'll see. It is important to add, especially in long scans like this one, that it is very important to add -v, so you can see in real time what is happening with your scan. And like in this case, you are going to get a lot of information without waiting for the scan to finish. Now we are going to use the flexibility of Nmap and learn how to specify the specific network interface and run a scans through that network interface. Knowledge about interface selection and basic knowledge about interface is very important, for example, when testing a network connection or any kind of problems inside your network. Or it is very important if you are dealing with multiple network interfaces and to see which you are going to use for a specific task. But before the nmap command, we are going to use two specific commands that are not nmap related. Inside your terminal, type in IP-link show and then press enter. So using this command, we are viewing the state of all available network interfaces. And as you can see, here are the names of the interfaces as well as the MAC addresses. ETH0 is the name of the network interface that we are using, and under link ether there is a MAC address. Also, you can use ifconfig in order to get even more detailed information about your network interface. Now get back to your Windows host, Windows operating system, go to the Nmap Zenmap installation directory. On the free space, press Shift and right click, then open command window here in order to open the Windows terminal. Then type ipconfig, not ifconfig like in Linux operating system. So here you can see even more information, primarily because this is a host operating system that hosts the virtual machine that we are using. And in the bottom you can see there is VirtualBox Ethernet adapter and information about it. Now let's get back to our Linux environment and test the scanning through our specified network interface. So go ahead and type nmap-e eth0 and we are scanning scanme.nmap.org. We are using eth0 because it is the general interface and the only interface used on this machine, but if you have multiple interfaces, of course you can use them. So press enter and wait for result. In the end, this does not grant us or gives us any different results without specifying the specific interface, but this can be very useful in the case when Nmap cannot select the interface automatically, which can happen from time to time. Rarely, but it can happen. And it is pretty useful to check if specific interface is actually working. In the case that you are conducting network audit or penetration test, it's always a good practice to check if the specified network interface or network interface that you are using is able to communicate properly with your network. So we are going to do that with a ping scan that will force a Nmap to use a specified interface. Just as before, but we are trying this on a local network. So it's pretty straightforward as before. Just type in nmap-sp-e eth0 and choose one host or address from your local network. And we demonstrated how to find local hosts on your own network in the previous steps. As you can see, unfortunately, we needed to repeat this command on a different local address, but it doesn't matter. So we can see that our network interface can successfully communicate with the local network. And that is what we are looking for in this case. Now you are going to learn how to use NSE scripts and how to utilize them in penetration testing and network assessment. In every case, you are going to find NSE scripts very useful in your day-to-day work. In order to begin, in your terminal type in nmap-sv-script http title against scanme.nmap.org. With the argument --script, we utilized NSE scripting engine inside Nmap. This is basically a scan within a Nmap scan where a parallel thread or parallel NSE thread where NSE scripting engine is initialized and the specified script is being run within a Nmap scan. There is great variety of NSE script, both supported and not supported by Nmap, that can be used for a great variety of tasks and purposes. This particular script, HTTP title, is used for displaying HTTP title in the output of Nmap scan. Since we are scanning scanme.nmap.org, the HTTP title is go ahead and scan me. Also, by adding comma after the HTTP title, you can add another NSE script and run it within your scan. For this example, we are going to use HTTP headers. It is very important not to forget to remove the white space behind a comma when you are adding another script. So in this case, after comma, there should be no blank space at all. And if you leave the blank space after the comma, you are going to get failed to resolve error in the output. In the end, this is a great example how can we run multiple NSE scripts in a single Nmap command. By doing just --script vuln, we can run all the scripts that are in vulnerability category inside NSE scripting engine and libraries which are located inside Nmap directories. Now we are going to demonstrate what the Nmap is doing in the background when running a NSE script just by adding -v on the end of nmap NSE command. In this case, Nmap has loaded 105 scripts for scanning, which all belong to vulnerability category. In the right terminal, I'm going to run another example, which is nmap-sv, and I'm going to tell the Nmap to run all the scripts from version and discovery categories by putting them inside quotation marks. Now I'm going to run all the exploit scripts from the exploit category inside NSE scripting engine. If we are using multiple NSE scripts from a same category, we are going to use the quotation marks or commas behind name of the scripting category. So we can include multiple NSE categories inside a quotation marks, or we can only separate them with a comma. Also, there is a way to exclude a specific NSE category by putting inside quotation marks not exploit, for example. This will run all the scripts except the ones in the exploit category. Since these kinds of scans can take literally forever, we are going to pass on to the another examples. Let's say that we want to run a specific NSE category, but we do not want to run two NSE scripts within that category, so there is a way to exclude them. We are going to do that by typing in nmap-sv script and inside quotation marks open a parenthesis, type in http -wildcard, close the parenthesis, and then add not. Again, open the parenthesis, type in http slow loris or http brute, close the parenthesis and close the quotation marks, and then add the target that we want to scan. In this case, everything except http slow loris or http brute scripts will be run from inside http NSE category. While we wait for a scan in the right terminal to finish, we are going to check what is happening with the vulnerability scan in the left terminal window. When scanning with vulnerability category NSE scripts, when we get the output, it is important to check for CVEs, and we are going to paste that CVE ID and Google it or search for it on the internet. This way you can identify and connect exploits to a specific vulnerability. As you probably expect, you can find a lot of details regarding the CVEs or vulnerabilities. There are a couple of script categories, which are auth, broadcast, brute, default, vulnerability actually, version, safe, malware, intrusive, fuzzer, external, exploit, denial of service, and discovery. All of these categories have a great number of scripts inside them, and many of them can be easily used and utilized in conducting penetration tests, security assessments, and basic or more advanced administrative tasks. Now we are going to do DNS brute forcing. The best way to begin is to start with a simple nmap command. Type inside your terminal nmap-script DNS brute, and you can use nmap.org as a target. If you want, you can use scanme.nmap.org. In this case, it doesn't really matter. Now we need to wait for the nmap to finish. This script attempts to enumerate DNS hostnames by literally brute forcing and guessing a common subdomains. It was developed by a guy nicknamed Cirrus, and this script attempts to discover new hostnames by brute forcing the target's DNS records. So it iterates through a hostname list, checking if the DNS entries exist to find and compare them to a valid records. The default dictionary that is used by DNS brute is located in a nmap directory or nmap installation directory. As every nmap script is, this one is also flexible. We can add -p80, for example, in order to add a specific port that we want to do this DNS scan on, but that is not needed since we are scanning for DNS names and not specific ports on a host. And if you really want it, you can add -v to increase the verbosity of DNS brute script. One of the most important nmap features, and one of the most widely used nmap features, is OS detection. OS detection uses TCP/IP protocol stack because it is the most widely used protocol, that enables multiple computers that use different hardware and software to communicate over the network. The syntax of operating system scan is very simple. We just type in nmap-O, and we can use host, for example, scanme.nmap.org. I mistyped the hostname, but again, it works okay. Probably the DNS is fixing that for me. We can see that OS fingerprinting option in Nmap doesn't like to work without port scan. User-submitted fingerprints are making this type of scan very reliable because users are submitting the OS fingerprints to the Nmap database. When you conduct this scan, Nmap compares contributed OS fingerprints from users with your own result, and thus by that comparison generates your output. Nmap OS scan by default does a maximum of 5 tries when conducting the OS scan. We can modify that behavior and increase the number of OS tries. If in any case Nmap cannot find exact OS match within its database. It is very simple, just add --max OS tries within your nmap command. The maximum number of OS tries that we can assign to nmap is 50. This methodology is not recommended since nmap's OS scan mainly depends on user-submitted fingerprints and OS detection that almost completely relies on comparison with user-submitted fingerprints. UDP services sometimes can be used to compromise a specific host, and Nmap gives us the option to do UDP-only scans. So open up your terminal and type in nmap-su-p-, which means we are going to scan all possible ports, and we are going to use a scanme.nmap.org as a target. After that, open another terminal, drag it to the left side, and add "F" to the UDP scan. You even can include verbosity if you want. The first scan that we started is taking very long because we specified that we want a Nmap to scan all ports for us. In the left terminal we have port 123 opened, it's running through a UDP protocol, and it is service called NTP. In the right terminal we specified the full range of all the possible ports, but we are going to do it a bit differently in the left terminal. We are going to run a UDP scan with specific port range, which is from 1 to 400. Just type inside a terminal nmap-p1-400-su against scanme.nmap.org. It is very important to add that you cannot use fast port scan or -f if you are using a specific port range or a list of specific ports. But you can use fast port scanning without specific port selection. Nmap's UDP scanning technique works in the following way. Basically, a UDP packet is sent to the target with an empty UDP payload, unless one specific payload is specified. If the UDP port is closed, an ICMP port unreachable message is received back from the target. And if the port is open, then the UDP data is received. If the port does not respond at all, we assume that port state is filtered/opened. Filtered means there may be some kind of firewall or IDS behind the port. IP protocol scans are enabling us to see which protocols are supported by the hosts that we are scanning. Technically, this type of scan is cycling through the protocol numbers rather than the TCP or UDP numbers. The protocol scan iterates through the protocols found in the nmap-protocols script, and it creates IP packet for every entry. we have TCP, ICMP, UDP, IGMP, and SCTP. For the rest, if there are any, the Nmap will use empty IP packet. We are going to start with a scan nmap-s uppercase O against scanme.nmap.org. Here the protocol number 1 is opened and it is ICMP. In the left terminal, I'm going to try the same scan, but just against my local router. Just press enter and wait for the Nmap to finish. Again, we can see that we have one, or ICMP protocol. Now I'm going to add -v and switch the scanning target to another network router in my local network. Here we have protocols 1 and 6, which are ICMP and TCP. When we are checking for firewalls behind ports, we are looking if a port is filtered or not. Now we are going to use NetDiscover in order to scan hosts on our local network. Then I'm going to take one host, for example my own host computer, and then run a command nmap-s uppercase A and paste the address. Nmap says that all ports on this address are filtered, which indicates that there is some kind of firewalling or filtering. The states of ports are pretty simple. These are opened, closed, filtered, and unfiltered. Open means that service behind that port is listening for the connections towards that application or computer. While filtered means that a firewall or some other kind of network obstacle is blocking the port itself. If a port is closed, that means that a service or application is not listening to outer connections towards that application or computer. And in the case when we have unfiltered ports, then we cannot be sure if the port is opened, closed, or firewalled. It basically means that the Nmap is not able to determine the correct state of that port. Sometimes we can have a combinations of port states. If you, for example, see opened/filtered, then the port is either opened or filtered. And if you see closed filtered, then again it means that it may be closed or filtered. Now let's run a firewall discovery scan on port 80. Just type inside your terminal nmap-p80-s uppercase A against the host that we want to scan. And if we see in the output that the port is filtered, then we can be sure that there is some kind of firewall or network obstacle. This way, by using -p prefix, we can even scan a range of ports as we used to do in previous examples. And again, we can use -p to scan all available ports. This will do a port discovery on all possible ports, but remember that these kinds of scans, all port scans, can take a very long time. Nmap scripting engine enables us to match the publicly known vulnerabilities to the service versions that we have detected through our scans. This time we are going to begin with GitHub. Go to your browser and navigate to github.com/cypeg/vulscan. Copy that link and go to your Linux terminal. Use cd to navigate to the nmap directory. Then do the cd to go inside a scripts directory. Then we are going to clone that github.com/cypeg/vulscan repository inside our scripts directory by using git clone and then just paste the link from the browser and press enter. Then go to your browser and then paste this link, go back to your terminal, use a wget command, then paste the link that I'm going to provide in video description and documentation. By doing this, we have saved the script that later we can use in Nmap scanning. Now we just need to check if a Nmap is working when we invoke the script. So we are going to use nmap-sv script vulners against scanme.nmap.org. Looks like we got a segmentation fault error, but we are going to try to fix that. So behind -- script vulners, just put -sv and run the script. As you can see, we got a great number of CVEs in the Nmap output. CVE means common vulnerability and exposure. And by identifying those CVEs, we can search for exploits on a specific service version. There is a way, very creative and cool way, to spoof the origin of port scanning. We are going to achieve that by using zombie hosts in our scanning. And in order to do that correctly, we need to find addresses with incremental IP ID sequences. We are going to achieve that by using NSE script IPIDSec. Just use that script in a nmap command by typing in --script IPIDSec against a full range of local addresses. And addresses that could be used as zombie hosts will return the incremental in the output. In order to conduct zombie host scan, just type inside your terminal nmap-pn-s uppercase I 192.168.7.1, which is a zombie host that we are going to use, and then we are inputting the target host that we plan to scan using this technique. In this case, I'm going to use the address that ends with 7 and 102. This is very useful and stealthy concept at the same time. It is discovered in 1998 by Salvatore Sanfilippo when he realized that by forging IP ID sequences and analyzing packets, the origin of the scan can be spoofed. And by exploiting that methodology, we can scan hosts without revealing our true origin. Another option for discovering potential zombie hosts is using OS scan with verbose mode. Just type in -sv-v-o against scanme.nmap.org. If in the output the IP ID sequence is all zeros, then we cannot use this host as a zombie. And indeed, the output says it is not. So we can see IP ID sequence generation all zeros. Now, instead of using the host name, I am going to use the address of the scanme.nmap.org. Now I'm going to just copy and paste the address after the --script IP ID sequence. And as we can see, indeed this address is not at all suitable for zombie host scanning. Routers, printers, IP cameras, and similar devices can all be used as a zombie host because most of the time they are not active and they are idle. Most of the time, ping scans are used for detection of live hosts inside a network. -sp, which we are using for default ping scan, uses TCP/ACK and ICMP echo requests to find live hosts. But if there is a firewall on the way, then we would not be able to see those hosts. So there is another scanning method that may come in handy. It is a TCP SYN scan. Let's do a couple of them right away. -sp tells Nmap to perform a basic ping scan, which will only consist of discovering the online hosts. Then after that, -P and S forces a TCP SYN scan. So this type of ping scan will discover hosts behind a firewall, if we are lucky. So in this case, it sends a TCP SYN packet to port 80. If the port is closed, the host will respond with a packet that is specifically in this case a RST packet, and if the port is open, the host will respond with a TCP SYN ACK packet indicating that a connection can be established. and after that an RST packet is sent to reset this connection. And at last we have CIDR notation, which is /24. It is used to indicate that we want to scan all of the 256 IPs in our own network. Let's try a regular ping scan with -sp. We can see that this host is up and nothing is blocking our ping probes. But the question is what to do if a host is down. We just add -uppercase P and S, and after that we can add the port numbers. We can add ports as a range, or we can add them separately, like in this case. Just put a comma behind every port number. And if we want to do a port range, just put a dash between the, for example, port 80 and port 1000. And all ports in between are going to be included in the scan. Here we have a ports from number 1 to 1000. We already mentioned that during a TCP/SYN ping scan, the Nmap uses the RST packets to determine if a host is live or it is responding. But it is very important to say that some firewalls are configured specifically to drop RST packets. So in that case, the SYN ping scan will fail. But unless we specify a port that we know that it is open. If in any case we do not know what port is open, then we just enter a range of ports, or we can enter a port separately just by separating them with a comma. Now we are going to use TCP/ACK scans. The Nmap's default scan, as we already mentioned, uses a ACK and ICMP echo requests at the same time in order to determine if a host is responding. We can use a TCP/ACK ping scans to determine if a host's firewall or some kind of a defense mechanism is blocking SYN or ICMP echo requests. It is very important to note that these kinds of scans will probably be blocked by most of the modern firewalls. So let's run a following script. Nmap-sp -uppercase P and A scanme.nmap.org. Let's run the same script again, but with -pn. So if with a regular -pa prefix the host is shown as offline, we need to try the TCP/SYN ping scan with the same host. As in previous video, we are going to conduct the SYN scan with the use of -ps. So when using ACK scan, the host was not online, but when we used the SYN scan, then it was online. That means that something is blocking those ACK packets. Selecting ports in TCP/ACK scans is pretty easy. We just, after the -pa, add first port, then separate it with a comma. And we can add multiple ports that way. And if we want to conduct a scan on a range of ports, we need to put the dash between a port range. For example, 80-150, 1-1000, etc. Here we entered 21, 22, 81, 88, and 4444. All against scanme.nmap.org. Regardless of probes being blocked, I'm going to demonstrate a port range. This time I'm going to use 21-150. That means that this scan will include all ports between 21 and 150. Then again, when using a regular ACK ping scan, our probes are being blocked. But if we again add the -ps, which is the SYN scan, probably our host will be shown as online. And it is, one host is up in the output. UDP scans are also used for host discovery, but it has a slight advantage of detecting systems behind firewalls and other protections that only do a strict TCP filtering, but they leave the UDP traffic forgotten. The recipe for UDP scanning is pretty simple. We are going to use -sp -uppercase P and U and insert our target into our Nmap script. Again, we are going to use scanme.nmap.org. A Nmap will send empty UDP packet to ports between 31 and 338. If a host is responding, it should return some kind of a ICMP port unreachable error. But if the host is offline, then any kind of ICMP error messages could be returned. It is very important to select ports when conducting UDP ping scans because some services that do not respond to empty UDP packets, they will generate false positives when we conduct a scan on them. So they will simply ignore the UDP packets that we send to them, and the host then will incorrectly give us a mark that it is offline. So it is important that we select manually the ports that are most likely to be closed. Adding a ports in UDP ping scans is pretty much identical to the SYN or ACK scans that we conducted earlier. After -pu, we just add ports that we want to scan. Even ICMP ping scans are used for host discovery, so Internet Control Message Protocol, or ICMP, is used to exchange operational information between network devices, mostly information containing success or failure about a connection. For example, destination or service is not reachable. ICMP by that is different from TCP and UDP that are mostly used to transfer data. So right away we are going to conduct a scan nmap-sp-pe against scanme.nmap.org. Because that a -sp option is deprecated, you should use -sn, lowercase sn. Anyway, you can use both because the output will be the same. Nmap will recognize both. I'm going to now conduct the same scan but only using my own router inside my home network. The address that ends with 7.1. We can configure ICMP ping scans in order to bypass firewalls. We know that echo request is the standard ICMP ping query, using the -sp or newer -sn, but in fact we can do much more with Nmap. The ICMP can also specify timestamp request and address mask, with specific request packets of course, but the usage of those is to learn information such as address masks and current times. In fact, we can easily utilize those for host discovery. So timestamp and address mask queries in Nmap can be done with -uppercase pp and -uppercase pm. ICMP timestamp and address mask reply both will disclose that the host is available. So these two can be really useful because administrators specifically block echo requests, ICMP echo requests, while sometimes forgetting that the other two ICMP queries can be used for the purpose of discovering hosts on a network. -pp is timestamp reply and -pm is address mask reply. To begin with IP protocol ping scanning, we are going to start with a script. nmap-sp-uppercase po against scanme.nmap.org. This is one of the many host discovery options which sends IP packets with the specified protocol numbers in their IP header. So this technique sends different IP protocol packets and then waits to get response that is indication of online host. In order to explain that, it basically looks for responses using the same protocol as a probe it is using, or in other case looks for ICMP protocol unreachable messages, and by that it tells us that the given protocol is not supported on the target host. So both of these responses confirm that the target host is alive and active. And as you can see, by using packet trace, we can see behind the scenes what actually the Nmap is doing. I'm going to enlarge this window in order to get a better view. So here we have a ICMP, IGMP, and IPv4. But only out of these three, the ICMP packet actually responded. In the end, this is all that is enough to know that this host is online. We can manually set IP protocols by using the option -po. For example, we can use ICMP, which is number 1, IGMP number 2, and for example UDP, that is number 17. We are doing that by using the command nmap-sp-po, then after O immediately we can put a specific number, whether it is 1, 2, or 4. It depends on what IP protocols you want to put inside a script. ICMP is 1, IGMP is 2, UDP is 17, and TCP is 6. These 4 are the ones that you are going to use the most. When doing these scans, all the packets are going to be empty, but we can generate random data to be used within these packets, only with the option --data-length. And here I should have used uppercase O. So the command is nmap-sp-p and O, data length 100 against scanme.nmap.org. ARP scans, or Address Resolution Protocol scans, are single most effective way of detecting hosts in local area networks. So we are going to type in nmap-sp-pr and then 192.168.7.1/24. This is CIDR notation, and it means that we'll scan all of the 256 addresses in my local network. ARP ping scanning functionality is pretty simple. So ARP request is sent to the target, then if the host responds with an ARP reply, then it is very clear that that host is online. If we use the packet trace command, we can more clearly see what the Nmap is doing in the background. As you can see, when we run this script against my local area network, we got a list of devices. Those are devices that are connected to my network. Now, in order to see what exactly Nmap is doing, we are going to integrate a packet trace inside our Nmap script. When the script is executed, you can see that the ARP requests are at the beginning of the scan output. When the ARP reply shows us the MAC address of a specific host, then we know that that host is online. Even while using -ps, which is TCP SYN flag set inside a Nmap script, we can see by using the packet trace that ARP is still by default used by Nmap. But still we can force Nmap not to perform ARP ping scan by using the send IP command. In this case, after packet trace, we are going to type in --send-ip. That way we prevented Nmap from running ARP ping scan. It is pretty much straightforward to spoof your MAC address while conducting Nmap scripts. Only thing that you need to use is the --spoof-mac command, and after that simply enter the desired MAC address. We did not supply target address, but again we will retry the script and we will put the target address on the back after the MAC address itself. Discovering hosts using broadcast pings requires root privileges because the NSE script uses the raw sockets. If we use distro that has a default root account, then there will be no problems. But again, if you use regular Linux distros, you will need to use sudo command. Inside our terminal, we are going to type in nmap, then invoke a NSE scripting with --script, and then add broadcast ping. We did not add a target host here, but we will do that in the following command. We are going to run the same script, nmap-script broadcast ping, and then we are going to do it against 192.168.7.0/24. which, as you already know, means that we are targeting all 256 addresses in our local network. We can also increase number of ICMP echo requests by invoking script argument broadcast ping.num probes equals 5. And also we can increase the timeout by again using script argument broadcast ping.timeout equals, for example, 10,000. A higher timeout of the ICMP probes can be useful when scanning larger networks. A higher number of ICMP probes might be necessary when scanning a larger network. Also, the higher value of sent probes or higher number of probes will get more results when scanning on a larger network again. We are going to retry this command but with -v prefix in order to see what the Nmap is doing. Argument was a increasing number of probes, but this time we are going to change the argument part to a timeout where we will set a higher number in case we want to scan a larger network. The default timeout of ICMP probes is 3000 milliseconds, while the default number of probes is 1, and in our script we increase number of probes to 5. Since we increase the number of probes, now we are going to test a higher timeout, which in this case we are going to set to 10,000. I am going to run it again. As you can see, the script that we run is pretty much slow because we increased the length of ICMP payload, both in terms of timeout and in terms of number of probes. It is also pretty easy to specify the network interface for using broadcast pings. If we do not specify an interface, then the script will send probes using all of the interfaces that are available, meaning those interfaces with an IPv4 address. Before doing this, it is important to use ifconfig or similar command in order to identify what interface we may use or may not use, since nowadays it is pretty common to have multiple network interfaces on your computers, workstations or servers. So in another terminal window, just type in ifconfig if you are using Linux, but if you are using Windows, you are going to type in ipconfig. And when you are finished with identification of interfaces, just type in broadcast-ping interface equals ET80. In my case, this is the interface that I want to select specifically for this scan and this script. I just need to specify the target address, and of course I'm going to use 192.168.7.1/24, all 256 addresses in my network. Looks like unfortunately we need to repeat the same command a couple of times, it happens. Also, there is a very cool feature of broadcast ping scanning, which is adding a new targets automatically. So if any of the new hosts are found, the library of the NSC scripting adds a newly discovered target to Nmap scan queue. So any newly found host will be automatically and separately scanned by this new targets argument. It is important to add that we can modify the new targets argument with adding max new targets, where we will set a maximum number of targets that Nmap will scan automatically. It is pretty easy to set a maximum number of targets just by typing in max-new targets equals the number of targets that we want to scan automatically. Just add the number after new targets and run the script. Nmap enables us to hide our traffic with random data. Most of the time, packets generated by Nmap scans are easily detectable by defense mechanisms implemented on the systems and servers. So, by using random data as payloads, we can decrease the possibility of detecting and blocking our probes. So we are going to add 300 bytes of random data in our Nmap scan. The concept is pretty easy and familiar. We are going to launch a scan, nmap -lowercase s, uppercase s, then -uppercase both p and s, and then --data length. And after data length, just type in 300 and add a host that you want to run the scan against. In this example, we are going to use scanme.nmap.org. Unfortunately, our probes are being blocked, but we are going to try that on another address. Let's use nmap.org, and also that is not working as we intended, so I'm going to try something on my local network. I'm not even surprised because I don't even recount how many times I did a scan against scanme.nmap.org. Let's run it against 192.168.7.1. We executed our scan, and in order to remind you, this is a TCP SYN stealth scan -ss, and after that we are doing a SYN ping scan, which is -PNS. Here we included 300 bytes of random data as a payload that is sent in packets. It is important to add that the length must be an integer between 0 and 65,400. But in any case, nothing over 1,400 is not recommended because it may not be possible to transmit those packets within a payload due to a network MTU limit. MTU is maximum transmission unit, and it has its own limitations. To make it simple, it is the largest size packet or frame that can be sent over a network. Its maximum is 1,500 bytes. If we add 0 to the data length argument, then we will force Nmap not to use any payloads. In total, this methodology will slow down your scans, but it will make your scans less suspicious to system administrators and automated IDS and firewall systems. With a forcing of DNS resolution, we can gain very valuable information. The administrators behind the main systems often assign the names that disclose the function of their systems. Often you can see names such as firewall, mail.domain.com, wireless, firewall, firewall1, firewall2, dev, etc. So we will use a command nmap-ss-ps-f-r. Basically what we are doing here is that we are telling Nmap to perform TCP SYN stealth scan -ss and then to perform SYN ping scan -ps. After that, fast port scan -f, and in order to always perform DNS resolution, we are going to use -r, and we are using 24 as a CID error notation. That means we are going to scan 256 addresses. And when we analyze the output and do a bit of research on members.linode.com, we find out that it is the default reverse DNS that is assigned to new Linode hosts. Our DNS is the querying technique of the domain name system, which determines the domain name associated with an IP address. It's basically a reverse of the normal DNS lookup of an IP address from a domain name. Beware that these kind of scans can sometimes last a long time. You can speed up the scan with a completely disabling the DNS resolution with the argument -n. In that case, you just need to replace -r with -n. Probably there will be a situation where you will need to exclude a host from your scan. If a specific machine or server or host does not need to be scanned in your particular situation, then exclusion from scanning is a very good time-saving option. Now we are going to use service detection scan -sv together with a OS fingerprinting -o, and then we are going to add --exclude, and the first two addresses that we are going to type in are the addresses that we want to be excluded from this scan. In the left terminal window, I am going to use netdiscover in order to identify what hosts I have up and running on my local network. Then I'm going to exclude some of the hosts from my scan. The hosts that I want to exclude are 7.102 and 7.105. And I'm going to separate these by the comma. And I'm going to separate the next part of Nmap script with a blank space, where I will use the range of addresses from 0 to 200. And as you can see, we successfully excluded the hosts that we wanted. Since we added verbosity, if you take a better look, there is no 102 and 105 hosts in the Nmap scan report. It is pretty useful, convenient, and uses normal Nmap syntax, so we should use it as a penetration testers and security professionals. And after a while we are going to use NSE scripts. In this case, we are going to utilize broadcast scripts in order to gather network information. We already mentioned that a couple of times, but NSE scripting is a very powerful feature of Nmap. We are going to run a script without a specific target. We are going to type in inside a terminal nmap --script broadcast. This one will run against all hosts on my local network, and it will use all available NSE scripts in the broadcast category. Now we are going to wait for Nmap to give us output. And after the Nmap is finished with the scan, we are going to scroll up to see what we got. We can see all the different types of NSE scripts inside the broadcast category, but we are going to use some specific scripts and we are going to assign them manually inside our command line. Next specific script that we are going to try is sniffer with timeout of 30. Timeout of 10 seconds is default, but it is not enough for anything from medium to large network. It is a script that scans and sniffs a local network for a given amount of time. Default is, as we said, 10 seconds, but we are going to set it to 30. And it will, as an output, print out discovered addresses. So let's run the script and wait for output. Looks like we are going to need to fix this script by adding a broadcast after the first -- script argument. As you can see, we got pretty big chunk of information that later could be utilized in our security work. Let's give a try to something else. We will use broadcast category of scripts by specifically using broadcast ping and with argument of new targets, which means that Nmap will more comprehensively scan the new targets that it discovers. And I'm going to do that on a CIDR notation 7.1/24, which means that it will scan all 256 addresses in my network. If you check a official Nmap broadcast category on their website, you will see that there are many useful scripts that you can use in order to make your penetration testing better and more precise. In order to list HTTP methods that are supported by a specific server, or more specifically web server, it is smart to use an NSE script that is called HTTP methods. This NSE script will find out what is happening by sending a HTTP options request. The options method in HTTP communication is used to describe the communication options for the target or specific resource. As a penetration testers, we need a very quick method in order to list all the HTTP methods that are supported by a web server. So let's run a script inside a terminal. nmap-pat, 443 -- script HTTP methods against scanme.nmap.org. Press enter and wait for a script to finish. We are doing this against port 80 and 443 because most of the time the web servers are exactly running through those ports. In order to individually check the code response of the HTTP methods returned by the options request, we can modify a Nmap script by argument HTTP methods.retest. We just modify our existing Nmap script by -- script arguments and then add HTTP methods-retest. After running the script modified, we can see HTTP response codes in our output. It is possible to put more than one HTTP request in a single packet. The HTTP by default tries 40 requests and adjusts the number according to the traffic conditions, all based on keep alive header. Keep alive header is a header that sends a hint to a sender of packets about how connection may be used to set a timeout and a maximum number of requests. By using HTTP pipeline equals the number that we want inside our NSE script, we are setting a fixed number of pipeline requests. Bear in mind that HTTP pipelining is not enabled by default in modern browsers. This is a simple way to hide your real address from the target that you are scanning with just a simple NSE script. It attempts to connect to a google.com through the proxy and then checks for a valid response code. If a target is an open proxy, then the script will cause the target to retrieve a web page from google.com, thus hiding your real origin. So we begin with Nmap and invoking NSE scripting with -- script HTTP open proxy on port 8080. As a target, we are going to use scanme.nmap.org again. Here we are searching for a open proxy on a target host. And as we can see, there is no open proxy on scanme.nmap.org. That particular service is not running over port 8080. This script can only be used on a hosts that are susceptible to a open proxy scanning through Nmap. In this case, the only thing that you are looking for is the open state on a service HTTP proxy over port 8080. Also, there is another way to disguise yourself while conducting a Nmap scan. We can achieve that by changing your user agent, more specifically HTTP user agent, to something other than Nmap's own default HTTP user agent. This way we can sometimes avoid blocking of our Nmap requests, because various firewalls are blocking anything that uses Nmap's default HTTP user agent. This we are going to achieve by using NSE script that goes over port 80, so nmap-p80 -- script HTTP trace. In this case we are going to try a HTTP trace NSE script. Again, script argument, then we are going to use after the script argument HTTP user agent that we will set to Mozilla 42, and then our target is scanme.nmap.org. This script argument we can use in combination with almost any NSE script. If it doesn't work properly the first time, just try again. It is very simple and easy to do. Basically, we just conducted a HTTP trace NSE script using another HTTP user agent, this time Mozilla 42. We cannot discover directories manually. Even if we do that, it would take too much time. We use the NSE script HTTP enum in order to enumerate directories that are used by popular web applications and servers. We have web scanners such as Nikto and others, but this specific NSE script takes it much further by doing a advanced pattern matching, as well as having the ability to identify specific versions of web applications and web software. By default, this NSE script only outputs 200 OK and 401 authentication required response codes. To begin, we are going to run this NSE script. It is in our usual format, -- script HTTP enum on port 80 against scanme.nmap.org. Since we did not get anything especially interesting, we are going to rerun this script against nmap.org. Same story again, so we are going to run it against my local router. We will use the same script again, only against 192.168.7.2. And we should get more interesting content in the output this time. And as you can see, there are many results, some of which are indicating what type of the attack vector or attack that could be used against a specific directory. Let's run the same script again, but only with different HTTP user agent. We are going to use Mozilla 42 user agent. And while we wait for our script to finish, we are going to use our left terminal window, where we will change the number of requests for a network packet using HTTP pipeline NSE script, in combination with HTTP enum. This is recommended practice since it can speed up this kind of NSE script. Because it doesn't work right away, we are going to repeat this scan. We are using this NSE argument based on our network conditions. Nmap enumeration NSE scripts are integrated inside a Nmap, so it's very easy and convenient to invoke NSE scripting with a enumeration and directory listing scripts. Using a HTTP userdir enum, we can try to enumerate valid usernames on web servers. This is a NSE script which enables us to perform brute force attacks using word list in order to enumerate user accounts in Apache web servers. This only works on the ones that have mod userdir enabled, which is Apache module that allows user-specific directories to be accessed using the URI syntax, which in total creates considerable security risks, for example, like the exposing of usernames. We are going to try the NSE script HTTP userdir enum against a router on my local network. It is the one that resides on a address 192.168.7.2. The Nmap will then output the list of potential usernames. So the script basically queries a non-existent directory to record the status response of an invalid page. After that, it tries every word that we have in a dictionary, basically testing URIs and looking for a HTTP status, which can be both code 200 or 403. This will indicate a valid username. If a server responds with 200 or 403, then it will stop. With usage of userdir.users argument, we can set a custom word list that the Nmap will use in this case. This time we only specify the default Nmap word list, but inside a script argument we can add any word list that we like. By using Nmap, we can also find possible XST vulnerabilities. They are caused by the existence of cross-site scripting or XSS vulnerabilities in servers where the HTTP method trace is enabled. When we want to check for XST vulnerabilities, we are checking for a trace method. And of course, we are doing that by using NSE script. And just for a reminder, we have get, head, post options, and trace HTTP methods. So right away, we are going to run a command in our terminal, nmap-pat-script http methods, http traced -script arguments, http methods retest against scanme.nmap.org. The scripts http methods traced and script arguments http methods retest, they tell Nmap to launch NSE script http methods and trace on port 80 if a web server is detected. HTTP trace sends a trace request and looks for a 200 status code. If a trace is not enabled, then the web server is not vulnerable to XST. Attackers can execute malicious code on user's browser using XSS vulnerabilities. The script that we are going to run basically spiders a website and attempts to identify output escaping problems, where the content is reflected back to the user. So the script then tries to inject or insert a strings of symbols and characters and to see if they were reflected back onto the page without proper HTML escaping. So in your command window, type in nmap-pat-script http and save output escaping against sudo.co.il. add -v for verbosity and run the script. Sudo co-il is a website with intentional XSS vulnerabilities. It has 19 levels and it's made for you to practice cross-site scripting. That is the sole reason why I am using it as an example here. Since the Nmap script did not output anything interesting, we are going to rerun it and maximize this terminal window. As you can see, we have unsafe output escaping in our output, especially there are characters that are reflected in a specific parameter. But in the case that we are working with PHP server, we need to modify the command itself. Before HTTP unsafe output escaping, we need to add HTTP PHP self -XSS. And this way we can check PHP servers for XSS vulnerabilities. Separate the arguments with a comma and run the command. The unsafe output escaping was written by Martin Holswende, and it basically crawls a web server to detect the possible problems with the way that web applications return output based on our input. So basically the script inserts the very interesting payload into all the parameters it finds. And here is the payload. It begins with GHZ. In order to clear this up and give you the better picture of what is happening, this script crawls the web server to create a list of PHP files. Then it sends an attack probe to identify PHP self XSS vulnerabilities. That means that it refers to the reflected XSS vulnerabilities. And that is all caused by the lack of sanitation of the variable PHP self in PHP scripts. Stored cross-site scripting means that some data, usually persistent data, is not sanitized in a page, which gives us indication that everyone can be affected by that vulnerability. A good example was MySpace XSS worm, which basically impacted 1 million users in less than 20 hours. On the contrary, we have reflected XSS, which means that non-persistent data, mostly data provided by the client to a form of submission, which is not escaped. So, you can imagine a search engine where the results are pre-displayed and not sanitized. Then in that case, you could put a HTML code on your search query and you will execute it. But then it's much less than a vulnerability than a stored XSS. Now let's check what crawling utilities are allowed on a specific host. Just run a command in your terminal, nmap on port 80 script HTTP user agent tester against my home router because it has integrated web application as its control interface. We will use the script in a case where we want to know what kind of crawling utilities are best for crawling through web directories of a given web server or a web application. Here we can see an output of web crawling applications that are allowed on this host. The background workings of this script are pretty simple. Basically, it sets various user agent headers that are used by different utilities and crawling libraries. And if the request is redirected to a page different than a valid browser request would be, that means that this utility is banned. And those that are not banned are ending up in our output. When conducting penetration tests, this way we can avoid unneeded troubleshooting and problems. Now we are going to deal with SMTP. It is short for Simple Mail Transfer Protocol. It is used for sending email messages between servers. And of course, we can assess this protocol from a security perspective by using NSV script. So let's start by typing in a script in our terminal window, nmap-sv-script smtp open relay against this address 41.139.077. I just pasted that address from a clipboard and added -v as verbosity argument at the end. I am going to make space for another terminal window and explain to you in more depth what we are exactly doing here. Open relays exist on SMTP servers configured in such a way that they allow anyone on the internet to send email through them. Considering that, it was a fact that those open relays were widely abused. At a present day, Most relays were closed or were basically put on a blacklist by other servers. And if we scroll up, we will see that there are no detected open relays on this host. By running SMTP Open Relay script, we are issuing a predefined combination of specific SMTP commands. By using this script, we want to check if a SMTP server is vulnerable to mail relaying. Since mail servers often store very sensitive information, I'm going to demonstrate how to brute force SMTP passwords. In this case, we are going to use local service named postfix, and then we are going to run it. Inside your terminal, type in service postfix status in order to see the status of the service, and then start the postfix service by typing in service postfix start. And we clearly see that service is running. Now we are going to run basic Nmap scan in order to see what is happening on port 25. We will use -f in order to quickly scan all the ports that are running on localhost. In the output we can see that SMTP service is running over port 25. Now I am going to stop the postfix service and run the Nmap scan again. Just summon the previous command in your terminal and run the scan. And as you can see, there is no SMTP service. Again, I'm going to start the postfix service in the left terminal, and in the right terminal, I'm going to run SMTP brute NSE script on port 25 against localhost. Before that, I'm going to run fastport scan just to check if SMTP is running, and then I will proceed with the NSE script. In your terminal, type in nmap-p25, then --script smtp-brute against localhost. Unfortunately, on my local SMTP service, I did not put a password or username, so the script will not give us the output that we expect. Regardless of that, I'm going to show you what output you are going to get when running a brute force dictionary attack against SMTP service. The output is pretty clear and easy to understand. We have account names or usernames and passphrases or passwords. In this example here, ACC0134 are usernames and test, password and 12345 are passphrases or passwords. Identifying usernames behind SMTP servers and web applications is very important when conducting penetration testing. All that we can achieve via usage of NSE scripting. So we are going to check a status of postfix service by typing inside a terminal service postfix status. We can see that postfix service is active and it is working. In the right terminal, we are going to conduct a fast port scan using nmap-f against localhost, which is 127001, and using -v add the verbosity at the end. Service SMTP is active over port 25. Then I am going to open Mozilla Thunderbird and check for my credentials. Those same credentials I'm going to test again, but only using NSE script. So we concluded that my username is root, and we are going to check that in a different way in a second. After checking SMTP and my credentials and usernames, I'm going to run a Nmap scan. Open a terminal and run nmap-p25 --script smtp enumerate users, basically SMTP enum users against localhost. Add -v at the end. Fortunately, the script was very fast and we verified that my username indeed is root. This method of enumeration is very simple and easy to conduct. It enables us to enumerate usernames behind SMTP services. In the next variation of this script, we can choose what methods of enumeration to use. So inside a terminal, type in nmap-p25 --script smtp nm users, script arguments smtp nm users methods, and then inside curly braces you can choose whatever out of these three to use: rcpt, vr, fy, and expn. rcpt defines the recipients of the message, Then we have EXPN. This one tells the actual delivery addresses of aliases and mailing list, and VRFY, it's basically user validation. And all of those are SMTP commands. SMTP servers use more commands than these three, but these three are the ones that mainly we are going to use for enumeration purposes. Looks like that we are going to need to retry this command a couple of times. It turns out in the end that we should run this type of command via usage of real address and not alias like localhost. So in any case, just type in 127.0.0.1. If you do not manually specify the order of these SMTP commands, then the Nmap will run RCPT as the first one. By using SMTP strange port NSE script, we are checking if a SMTP service is running on a non-standard port. 25, 465, and 587 are the standard SMTP ports. And if SMTP server is found running on a port other than that, then this NSE script will notify us. Again, we are doing it the usual way by using nmap-sv script, but this time SMTP, strange port, and against the address, in this case, that has a SMTP on a strange port. So press enter and wait for output. This script tells us that this mail server is running on an unusual port, which may indicate possible malware. It is recommended to run the script using -sv argument, which is service detection, because it will compare the port numbers on which SMTP servers were found against the known port numbers, which are 25, 465, and 586. And if SMTP is detected as a service, but it's running on a weird port, then something probably is not right. In order to obtain capabilities of an Nmap server, we are going to use command that is named capability, and it will allow us to list the capabilities supported by Nmap mail servers. Inside our terminal, we are going to enter a nmap-p143993 script Nmap capabilities and against address that we suspect that has Nmap server running. After the script is finished, then the results will be included in the output. And if in a case where we have Nmap server running on a non-standard port, we can use port selection flag -p or even enable Nmap service detection using -sv. So just type in inside your terminal nmap-sv script Nmap capabilities against the target address that you want. Be aware that these scans can sometimes take longer time than expected. As you can see, we have a very detailed output because we included the -sv argument inside our script. Nmap is a legacy email protocol and it is target for cybercriminals. And for administrators and developers, it is very hard to implement security measures on this kind of email protocol. To audit the capabilities of POP3 mail servers, we are going to use NSE script pop3-capabilities. By using this NSE script, we are going to ask for POP3 server for a list of supported commands. And also it will try to retrieve the version string with the implementation string, which means that it will try to determine the POP3 version. Enter inside your terminal nmap-p110 script pop3 capabilities against the target address. And in the output we have the list of supported commands. Remember that this script works equally well on POP3 and POP3S protocols. As much as we want to scan only one host, also while conducting penetration tests we are doing scans of multiple hosts. We already used this methodology, but now we are going to cover it in more detail. So inside your terminal, just type in nmap-a-o against 192.168.7.0-255. Here we are running aggressive scan with OS scan. By using 0-255, we are scanning all addresses from 0 to 255. Alternatively, we can use CIDR notation using slash, for example 0/24, in order to scan 256 addresses in this subnet. So now we are going to do things a little bit differently. So nmap-a-o 192.168.7.0/24. The results that we are going to get in this scan will be pretty much identical to the results in previous scan. Indeed, they are identical, but these are the two ways of doing technically same thing. Nmap features interesting and potentially useful feature that allows us to scan random targets on the internet. Inside your terminal, type in nmap-f-ir and add verbosity argument. You cannot use this nmap script without a specific number of hosts that you want to be randomly discovered. We are going to fix that by adding the number 10 after the -ir. This means that Nmap will try to discover 10 random hosts on the internet. IR argument tells Nmap to randomly generate 100 or 10 or 5 external IP addresses, and then to use them as a target in the scan. You can see that almost all hosts that Nmap generated are down. That means that either they are not responding or that they do not exist. That is the reason why this scan should be repeated a couple of times or set up in the beginning with a larger number of generated hosts. As you can see now, we are running a scan that randomly generates 1,000 hosts. And this one, believe me, can take a very long time. Since Nmap does not have control over the addresses that it generates this way, you should be careful because you may stumble upon a very, critical machine that is being monitored. The best advice that I can give to you is to research the legality of these kinds of activities. In every country there are different laws about scanning the hosts and port scanning, so be careful and stay on the legal side. We are going to stop the execution of this script and we are going to do another scan, but this time instead of 1,000 we are going to use 20 randomly generated hosts. And let's see what happens. So here we have a randomly generated address with scanned ports and a hostname. Hostname is not randomly generated, it was basically created by DNS service, a naming system for computers, servers, and services that are all openly related to the internet. Again, you can do a same type of scan, but against a specific port, for example, 4444. That means that Nmap will generate a hosts that are running some kind of service or applications on a 4444 port. As you can see, you cannot use -app, which is a fast port scan. If you specify 0 as a number of hosts for Nmap to generate, the Nmap will generate hosts indefinitely. So that means it won't stop until you tell it so, or until you break the execution of the script. We are going to stop the script and do something else. Actually, we are going to do something similar, but against a finite number of hosts. We'll use 20 for this example. Looks like that I'm going to repeat the scan a couple of times. And here we go. We have a Kerberos service against port 4444. That is about it for random scanning. Just be very careful how you are going to use it. Every Nmap scan breaks into different phases. By carefully selecting our scan flags and arguments, we can greatly improve the performance and the speed of Nmap scanning. We are going to run nmap-t4-n-pn-p- which means to select all the ports against a target that we want. By using -n, we are skipping the reverse DNS resolution, and by using -pn, we are skipping a Nmap ping scan. We pasted our target from previous scan, and while our scan is finishing, we are going to pass on to our left terminal window. Before that, in our right terminal, I'm going to terminate the scan that has been running and change the host, actually change the address with the hostname scanme.nmap.org. And almost at the same time, in my left terminal, I'm going to run nmap-p- against the same target. And since these scans are going to practically take forever because of -p-, which is Nmap flag for scanning all possible ports on a specific host or address. So we are going to change that into -p22, 81, 443. And I'm going to apply that on both scans, on both left and right terminal. This shows you how an exact definition of ports inside our Nmap flags can speed up our Nmap scanning. When we have only 3 ports to scan, in this case 22, 81 and 443, how fast we are getting our Nmap output. Let's repeat that with 22, 81, 443, 4444, 8080 and 445. And we'll do another scan using -p- in order to make comparison again. But before that, I'm going to fix a situation in the right terminal by adding 8080, 4444 and 445. So now in the left terminal, -p- against scanme.nmap.org is a regular Nmap scan that will scan this host for all possible ports. In the right terminal, we have -t4, which is aggressive timing template, -n, which is skipping off reverse DNS resolution, and -pn, which is skipping off ping scan. -p- is a flag that tells Nmap to scan all ports on this host. The option -t is used to set the timing templates in Nmap scripts. We have 6 levels of timing templates in Nmap. We can choose numbers or levels from 0 to 5. The first one, 0, that template is useful for avoiding detection systems, but it is insanely slow because only one port is scanned at a time and the timeout between probes is 5 minutes. So that's why it takes so long. The number 1 has smaller timeout between sent probes, but again it's very slow. Number 2 is used when scanning is not supposed to interfere with the target system. Number 3, that is Nmap's default timing template, and it is used when we do not set the -t argument. Number 4 is aggressive timing template, and this one is actually recommended for broadband and Ethernet connections. And at last we have number 5, that is the fastest timing template, but it sacrifices accuracy for speed, so it is not recommended. In the following video of this tutorial, we are going to talk more about setting correct timing templates in Nmap. When we are working with a large number of hosts, then time difference really adds up. But if we shorten the time, for example, of scanning of 100 hosts, then there is a lot of time that we are going to save. It is just important to understand what is that you are doing and what is your aim when conducting a specific type of Nmap scan. And by using that knowledge and understanding, just skip the tests that you do not need. Setting up timing parameters in Nmap can be a bit complex from time to time, but in order to avoid that complexity, we can use timing templates which are separated from 0 to 5. We have 5 incremental levels that we can use. I'm going to start with 4th level, which in Nmap flag syntax is -T4. So type inside your terminal nmap -T4 192.168.7.104. This is the address of a virtual machine on my network, but in your case you can use almost any device or machine that you have active on your local area network. This one I'm using purely for demonstration purposes. T4 is the aggressive timing template for timing parameters inside Nmap. And T3 is one that is by default used by Nmap when we do not assign a T flag inside our command. So anytime that you do not use T flag, the Nmap will run it as T3. We will talk about specifics of those Nmap timing templates in more detail later. Now let's focus a bit more on command line. Inside the terminal, type in nmap-t3 against the target that you want. After that, we have T2, which is used when we are not supposed to interfere with the target system that we are scanning. More about that later. We are going to terminate this scan because I assure you it will take a long time. And at least we are going to try T1, which is even slower, just for the sake of demonstration. At the end we have T0, which is insanely slow, but it is very effective in evading IDS systems. I'm going to terminate T0 timing template and use -T5, which is the timing template that sacrifices accuracy for speed of execution. When you compare the speed of execution between these different timing templates, you can see that there is a lot happening behind the curtains. So let's go into a bit more in-depth dive of timing templates and their levels and their specifics. We are going to use official Nmap sources in order to assess and explain the timing templates. As we already mentioned, we have 5 levels: T0, 1, 2, 3, 4, and 5. They all have different features, characteristics, and can be used for different purposes. The reason that we used finished timing templates instead of specific and custom timing parameters is that setting up a correct timing parameters can potentially consume more time than a scan itself. So that is the reason why we are using Nmap timing templates. Under a name column, we can see min RTT timeout, initial RTT timeout, etc. Different timing parameters. As we look to the right side, under timing templates T0 to the T5, we can see their values, and all of those values we can manually set up. Beginning from the 0, that template is useful only for strict avoidance of detection systems, but as I already said, it's painfully slow. That's why the Nmap calls it paranoid. Then we have 1, which is called sneaky. That template is useful for avoiding detection systems, but still it's very slow. We have 2 or polite, which is lighter version of T1. And then we have T3, which is Nmap default timing template, T4, the one that is recommended for modern Ethernet connections, and T5, the insane one that sacrifices accuracy and reliability for the speed of execution.
Hello and welcome. In this section, we're going to talk about how we can use a high-level programming language such as Python with Nmap. In this video, we're going to cover the setup. So basically, we will download anything we will need to start working with this. First of all, we're going to need Python. Now you can simply Google Python and download it from their official website. And after you have downloaded Python, go ahead and download pip. Pip is a package manager for Python. Now you can get it by using this command, or you can simply download the file from this link. Now you can see that this is a Python file, so you need Python to run this. When this is downloaded, simply run Python and this file. Now once that is done, you should be ready to go. We're going to use pip to download the Nmap library, which we will use. So some of you might have already installed Python sometime before this. To check which version of Python you have, type in python-v. Now you can see it tells me that I have Python 2.7. Well, Unix-based systems can have multiple versions of Python installed. If I run python 3-v, it tells me I have Python 3. The same is true with pip. So I have pip 2.7, and if I run pip3-v, I have pip 3.7. So you need to be very careful if you have both of these versions when we are installing packages. Alright, so here I am in my folder, both in the terminal and in my Word editor, which I'm going to use Visual Studio Code. You can use whatever one you like. Here I'm going to use pip, and of course pip3 because we want the latest version, and I'm going to pip3 install python3-nmap. This is the library which we will be using. Alright, now that that's done, I'm just going to clear my screen, and here in Visual Studio Code I'm going to make a new file called scanner.python.py, which is a Python file. And just to make sure I'm in the correct folder in the terminal, I'm going to list the contents, and there's our file, scanner.py. Now let's go ahead and do something very simple. So first I'm going to import Nmap3, which is the library which we just installed with using pip. Then I'm going to define the scanner object, which is done like this. Nmap. Alright, now we have the scanner here. And then we can do some stuff with the scanner. For example, we can scan the top ports of a site, and I'm just going to use an example nmapper.com. This is an example site. But when this command executes, we want some results from this. So I'm just going to say results equal scanner and this command. Now we can print the results to the user. Alright, now that this is done, whoops, we have a typo here, so nmap3, alright. To run a Python file, simply type in python3 and the name of the file, in my case, scanner.py, which should give us the output. Now you can see this is very unreadable since this is JSON, but it didn't format it. So I'm quickly going to take care of that. I'm going to import a JSON library in Python. And instead of just printing the results, I'm going to say json.dumps and then wrap the results here in parentheses and make sure to indent this by 1. Alright, now if we run our script, we should see a formatted output. Now we can see the top 10 ports of this IP address and other information which you might be interested in. So thank you for watching. We'll continue in the next one. Hello and welcome. In this lecture, we're going to take a look at doing some of the basic scans using our Python library. Now we're going to have to make a few changes in our code, since you can see here our scanner object inherits the Nmap constructor, which gives us access to some of these functions and scans, but we actually want to inherit from a different one, which will give us access to the basic scans available within Nmap. That one is called Nmap scan techniques. So now I want to inherit from that one, and also I want to comment out this line since this command will not be working anymore. So results equal scanner, and here you can see recommended a few scans that we can do, and the one I'm currently interested in is the Nmap OS detection scan, which I'm going to use. And then here in the parentheses we can type in the IP address. But what I want to do is I want to expect in a variable which is going to be input IP. So right after defining the scanner, I'm going to ask the user for an input. So I'll tell him enter an IP address. Alright. Then when the user enters the address, it will be stored in this variable, which will be then passed into the Nmap OS detection function. We should be able to run our script now, enter an IP, and I'm going to use the one that I've been using previously. And you can see I got an error here because some of these scans require root privileges. That's very easy to fix, simply type in sudo before we run our script. It's going to ask you for your password. And now again, let's enter the IP address and take a look at the output. The scans might take a while. And here we go. We can see we get the operating system, the accuracy of the scan, and similar information that we would usually get with Nmap. Thank you very much for watching, and until next time.